Okay, so today it's a review to start with of absolute values. Do you remember that we had some absolute values that came out impossible? The absolute values that were kind of like this. I want to show you graphically why that's not possible. Do you remember me saying that if you graph on the left side and you graph on the right side, you graph both sides and then see where they, what? See where they cross, see where they intersect, okay? So if I say y equals absolute value of x minus 3, do you get that's an absolute value graph that's been shifted 3 to the right? Do you agree that your calculator would give you a graph that looks something like that? And then, if it says that it equals negative 4, y equals negative 4, do you get that that graph would be down here? Do you get why there's no solution? They never cross. There's no solution to that. Why is there no solution to that? Because you can't have the absolute values come out negative. We actually then read in the rules, so to speak, for absolute values, how the absolute values can never come out negative. All right, one more thing. The absolute values come out to two things. And you can't start right here by adding 3. That's a classic mistake. At least the kid got this all down to just an absolute value. Let's say that there had been a 2 out here, and this had been a 16. They started by getting rid of the 2 and getting the clump alone. Divide by 2 on both sides and you get 8. But you cannot add 3. What do I have to do first? Separate in two equations. 2x minus 3 equals 8. And 2x minus 3 equals negative 8. Key there, this and this are identical except for one thing. What? That little negative. That's the only difference between those two equations. Okay? Would you please take a moment and solve these two equations? I'm going to pause for a second while you do that. A whole lot of adding 3 going on, right? That's pretty much all you do. But your answers come out to 11 and, negative 5. Totally different. Divide by 2. X equals 11 halves. And negative 5 halves. If your life depended on it, how could you check and see if that actually worked? Go plug them back in. And you'd put in 11 halves. Let's just do 11 halves because it'd be easy. Do you get how the 2 will cancel that and it'll make it 11 minus 3? And that makes 8. And the absolute value of 8 is 8. So it worked. Okay. Now, what are we going to do different? Well, we had some that were like this. Yuck. When there was absolute values on both sides. That added some complication. And I don't know if you noticed this, but sometimes when you solve these, even without the absolute values, let's say it was just 8 plus x. When you do this and you do the same exact process, you will often get a number that doesn't actually work. Don't forget to check your answers to see if there are any extraneous answers, as in answers that don't actually work. All right, I'm going to simplify it up just a bit and say it like this. X plus 1 is equal to x plus 4. I'd like you to solve that one. Be careful with the negatives. That's what it's all about in here. And then the next step is we're going to learn how to put in like a less than or equal to instead of just an equal to. But for right now, just solve this one. I'm going to take a moment. Let's see if you can find an answer for that one. All right, in case you're like skeptical, like, does this even work? Do you remember I just said a second ago that you could consider this a graph that's been shifted 1 to the left? And then this other one is the graph of y equals x plus 4, which like goes through this and has a slope of 1. Do you think it's going to cross at least once? Maybe even twice? Could it be once? Just once? Yeah, it could be just once. If these two lines are parallel, if the green one and the blue one here were parallel, then it would only hit once. But so if you're like stumped, if you're like, I'm not sure this is even going to work, you can always make a little sketch of what this would look like, what this would look like, and graph y equals this and y equals that, and see if you think they would cross. And if they would cross, then you know you're supposed to get an answer. Am I supposed to get 4 answers, though? No, I'm not. Think about that. How on earth could that thing touch each other 4 times? Not buying that. I could buy that it could have 2 answers. So the point is, if you end up getting 4 answers, something's wrong, and some of them don't work, and you should test your answers by sticking them back in. All right, so I'm going to pause for a minute again. Let's see if you've got them. All right, so a lot of people are done, and so I'm going to proceed. This will make 2 things. X plus 1 equals x plus 4. How do I know to do that? You just do the first one by taking away the bars. It's like there's no absolute value bars. And you do the second equation by copying the first equation and then saying to yourself, well, it can't be exactly the same as the other one. And this is an important part. If I just stick a negative right there, do you get, I just capriciously stuck it on the x. It could have just as much been stuck on the 4 because it could have been 4 plus x or x plus 4 is the same thing. So you can't just do that. Math isn't just random like, ooh, I happen to make this one negative. It's got to have rules. So you make both of them negative over there. Okay, so then this has become x plus 1 equals negative x minus 4. And then I solve it. I'm adding x to both sides. 2x plus 1 equals negative 4. Subtracting 1. 2x equals negative 5. X equals negative 5 halves. I'm suspicious of that one, that it might not work, but I can check it later. This one. And I get 1 equals 4. What does that mean? This doesn't exist. There's no answer for that one. Okay? So that isn't even giving me any answer. So it looks like maybe this is my only answer. Usually they don't all cancel out and not work. And I just showed you graphically that this one has to have an answer. They're going to cross somewhere. So negative 5 halves is probably it. Let me check it. If I take negative 5 halves here and here, I will get, let's see, that's negative 2.5 plus 1 makes negative 1.5. The absolute value of negative 1.5. And then I take this one and I get, I'm going to put this over 1, and I get negative 20 over 2, which is the same as negative 10. What, just negative? Wait a minute. I'm multiplying, sorry. Negative 5 over 2 plus 4. I did that all wrong. Try to fix this. Negative 2.5 plus 4. Negative 2.5 plus 4 is 1.5. Okay, good. It is going to work. There we go. I checked it. The absolute value of negative 1.5 is 1.5. It worked. So negative 5 halves was my answer. Phew. All right, now what would have happened if we would have said, let's go back to something a little simpler. Let's say this is just greater than 8. Do you get that there's a lot of answers that are bigger than 8? There's like an unlimited number of answers. They're going to make it bigger than 8. So if I looked at this as a number line, do you get that this has to have an unlimited number of answers? Okay. I want you to just think about less than 8 for a second along the same lines. Do you get that only works until it gets less than 8, works fine until you hit what? 0, and then it can't go negative. Do you get there's not an unlimited number of answers here? So it's more like a number line that's going to be between a couple spots and then it stops and it only works in there kind of thing? All right. So how do you get those spots? You go like this. X plus 3 is less than 8. And x plus 3 is, remember how I said you make it identical to the first one and then you figure out what's going on? There, I made it identical, but then this one's got to be negative. If that turns to the opposite of 8, do you get that the sign would have to switch then? Instead of less than 8, it's going to be greater than negative 8. Instead of less than 8, greater than negative 8. Now I'm going to solve these two things. Subtract 3. X is less than 8 minus 3. That was just an underline for emphasis, so I'm going to clean it up to make sure you see it's just not divided by. It's just 8 minus 3, which is 5. And here we have minus 3 minus 3. Underline was just for emphasis. And this is X is greater than negative 11. So now I make my number line. Here's 5. Here's negative 11. It's got to be less than 5, which means can't be 5, less than 5, and then bigger than negative 11. Here's negative 11, and bigger than that, so it's in between those two spots that it works. Once again, if your life depended on it, you might want to check to see if you got it right. What's something that's between negative 11 and 5 and is really easy? 2 is, true. Okay, so I split in 2. And then I get absolute value of 5 is less than 8. Hey, it worked. And I also said this didn't work, so let's try something bigger than 5, like 6. I put it in there quick, and I go 6 plus 3 is 9. Is the absolute value of 9 actually less than 8? No, it's not. So it shouldn't be working out here, so that's a good thing. I proved it doesn't work. All right, let's see if you can handle that. Here's one like it. I'm going to make it a little more complicated, just to add a teeny bit of rigor to it. Greater than or equal to 16. See if you can handle that. Greater than or equal to 16. Yes, you need to get the clump alone first. I'll pause for a second while you tackle that one. Okay, so complete the square. Let's see if you can learn this. Just to clarify, I hope you know how to solve a quadratic. That's something I'm sort of going in there assuming. Maybe I shouldn't. If you're going to solve this puppy, if you can factor it, you should, but that one wouldn't factor. So do you remember the quadratic formula? X equals negative b. Plus or minus square root b squared minus 4ac all over 2a. So if you don't know that, write it down. You got to have it memorized. It's going to be on your next test. Got to have that one. Okay, then to actually solve this, set equal to 0, you know, I need to solve that to get the solutions. That's one thing. To get complete the square helps you to find the vertex of it. So one thing at a time. To solve it, a is 1, b is 8, c is 1. You just stick those into that equation, and that would solve it. All right. Probably going too fast here, but you're in honors pre-calc, you're supposed to be able to do this. That's an 8. That's an 8. A is a 1 and a 1, and C is a 1. So this is negative 8 plus and minus the square root of 8 squared is 64 minus 4, which would be 60, all over 2. You've had those on your top 20s quite a few times, so I know you know how to simplify those. So there's two answers for it, and those are the two answers. But completing the square does something completely different. Completing the square on a quadratic like this will tell you the vertex. Let me just see if you remember what vertex form looks like. Remember when you like, oh, I have a parabola and I moved it 3 to the left and down 5. You know what I'm talking about? Here's my parabola. It's been moved 3 to the left, down 5. That's called vertex form, and it happens to have the vertex buried in it. Right here, it's 3 to the left, down 5. Okay? Negative 3, comma, negative 5 is the vertex. Now, how can I get that vertex without having to graph it, though? Well, I can just look at this and go, I know the vertex, because it's in vertex form. So what if I change this to an 8 and this to a plus 5? What's the vertex on that guy? Not 8 comma 5, you're close. Negative 8 comma 5. Good. Okay, so what's the vertex of this one? You can't tell just by looking, can you? It's just sitting there. So what do? You do this thing called completing the square. If you're going to complete the square, it gives you vertex form. That 8 is the key. That 8 tells you what we'd really rather have here. X squared plus 8x plus something would have worked perfect to give me vertex form. I'll tell you what it is. It's 16. If it had, it's like easy to say, well, if the problem had been this, it would have been easy. It would have been x plus 4 and x plus 4, which makes y equals x plus 4 squared. And why is that in vertex form? Because I could say plus 0, and the vertex would be negative 4 comma 0. So far, do you get what I'm saying? If this thing were factorable like this, where those two are the same, that's called a perfect square. Hint, the whole complete the square motif that we're going to go for here. If this had been a 16, it would have worked nice. Because then these could be combined together, and then my vertex would have been sitting right here and here. Just remember, always do the opposite of that one. Okay, so that sets up the y. But wait a minute, it isn't a 16 right there. So what you do is you just make it a 16 right there. I move this one over and say, I'm going to do that plus 1. I haven't changed my equation. I'm just moving it over. And I'm going to make this a 16, just like I wanted it to be. And you might be saying, but Mr. Server, you can't add 16 and keep this the same. You're right. So you add 16, and you then over here subtract 16. Now, if you add 16 and then subtract 16, it stays the same, doesn't it? It'd be just the same as if I added 16 in here and added 16 here, but then to get it over here, I'd make it minus 16. All right. Now, you saw me factor that part, so it works out perfect. It's x plus 4 and x plus 4, which is x plus 4 squared. And then I just have to finish the deal. Yes?
So minus 16 be minus 15, right?
That's what I was saying. I got to finish the deal. I got to put this minus 16 with this 1, and that makes a total of negative 15. What is the vertex? It's negative 4, negative 15. All right, I need you to try another one, but not trial 2 because that one's too tough. Try this one. X squared plus 4x plus 7. Hint, the first thing you do is make sure it's not a 7. So you move the 7 over and put in what would have been perfect right here. Now, how did I get that 16 last time? You have to do half n square. Half n square. Do you get what I'm saying? Half of this and square it. What's half of 4? What's 2 squared? 4. if that's plus 4, to make this be a perfect square, which it is now, it's x plus 2 and x plus 2. Cool, it works out perfect. But now I got to pay the piper. If I added 4, I got to subtract 4. Does that look like it's vertex form? Well, it's really close. So you just got to put the x plus 2's together. And now I can see the vertex. The vertex would be negative 2, comma 3. All right. It's just a small side thing, but something we're going to test you on, so I needed to squeeze that in. Solving quadratics, use the quadratic formula. But if you want to know their vertex, you can do this complete the square process. All right, I think that's enough of that for now. So I can show you how this formula came to be, but I'm not going to today, given how much time we have left, and I'm really trying to get you your 10 minutes of work time here. So, all right, we are going to go to, this is part of the quadratic formula. It's called the discriminant, and it tells you how many solutions you have. I remember this showing up on one of your tests also, so I want to talk it through for just a second. You remember how this is the part that's underneath the square root? If you get it the part underneath the square root is negative, which is what that is, then there's no solutions. If you're negative underneath the square root, the only thing you can do is stuff with the I, that's imaginary stuff, so there's no solutions. If you want to be technical, there's no real solutions. What if the part underneath the square root, b squared minus 4ac, is actually equal to 0? Then that means this, x equals negative b plus or minus square root of 0 all over 2a, because the b squared minus 4ac goes in there, right? If that part's equal to 0, do you get that then you don't really need to do a plus and a minus? Because adding 0 and minusing 0 are the same exact thing. So this can cancel with it. So cool. When you get 0 underneath the square root, there's only one solution. What if the b squared minus 4ac part underneath the square root, what if that part's positive? If that part's positive, then you have two solutions. Because you're going to have to do a plus whatever this number is and a minus whatever that number is. All right, so this is the one where if it's negative, there's no solutions. If it's equal to 0, there's only one solution. And by the way, it's the vertex. A lot of people don't add that in there, but I like to just throw it in as an extra little. If there's only one solution, then you've got x equals negative b over 2a, which you'll learn later is a way to find the vertex. That one solution that you do have is like this, and it's the bottom of the parabola. It's the vertex. And then if there's two solutions, you really don't know too much other than it touches twice. You don't know where those solutions are or if they're not the vertex. Okay. How could they ever test you on this? I've seen it on the ACT where they said, we know our parabola has two solutions, or we know our quadratic has two solutions. So what do we know? Do you get how you can go backwards like that? If we know it has two solutions, then what do we know? We know that b squared minus 4ac is greater than 0. Okay? If you know it's got two solutions, then the thing underneath the root must be positive. If it had only one solution, you could also do that. You could say if they were to tell you, the one I saw on an old retired test was, if it had two solutions, what does that mean? They could have asked, if it has only one solution, what do we know? That b squared minus 4ac is 0. And then you could actually solve your little equation. All right, so now let's get to your homework. And it starts right there. I thought I was going to have a lot more of that other stuff, but I guess that other stuff was more just a tag on to the end of absolute values. So obviously more about quadratics, and I apologize for kind of implying that all we had was that other thing. That was mostly just a recap of the stuff, the hardest stuff from yesterday. Okay, so if this is my quadratic, I hope you haven't just completely forgot what you learned last year. It's a parabola. It's been shifted up too. And right away, I can tell a lot of things about its y-intercept, its x-intercept, because by just looking at my little sketch, I know it doesn't have any x-intercepts. Get what I'm saying? If it's up here, it does not touch the x. Its y-intercept is really simple. The y-intercept is where x equals 0. I hope you got those memorized. I'm going to say it again. The x-intercept is where what? No. The y-intercept is where what? X equals 0. The x-intercept is where what? Where y equals 0. Okay, good. All right. And then what's its domain and range? Once you have the picture, they're so much easier. Domain is all reals. Range is from here up. And it's increasing from here over. It's decreasing in this little zone here, from here to here. Does it have a max or a min? Well, it's got a low spot, so it's got a min. All right, so we're doing 1 and 3. And it says we're required to do 1 through 23. I'm not making you do all of them. I think this one's good because it's got a negative here. And some people are going to be like, how am I supposed to graph that? And, of course, I hope they'll remember to go back to the what? What always graphs everything? Sad. XY chart graphs everything. If you're on the ACT test and you're like, my calculator won't work because otherwise, yeah, you'd use a calculator. You can get that graph by making any number you want. I stick in 0. For the x, I'm going to get the y-intercept, right? 0 goes in, and I get -7. Cool. 0, -7. That spot's on the graph. And then I know it's an upside-down parabola, so maybe it's like this, or maybe it's like this. You know it goes through there. I'd make some more points to figure out exactly where it is. All right, so I do want you to do number 6. We can skip our shirt 1. This will save us a ton of time. I think it'd be good for you to do this because it's a lot like the lab that you're going to eventually do with that tennis ball lab. That'll kind of help tie all this together later. So let's do this, and then we're skipping this. Number 7, just like a ACT question. Let's do lucky 7. We'll skip this. We'll skip this. Remember, what part is the discriminant? The thing that tells you the 1 solution, 2 solution, 3 solution. Which part is that again? B squared minus 4ac. Good. Notice it's not the square root of it. It's just b squared minus 4ac. So then, what's b in this case? In this case, it isn't b. It's actually, they renamed it to mess with your head. But it's still b squared minus 4ac. It's just they've renamed b to be m. That could be, except real ACT doesn't have 3-part questions. But anyway, that could definitely be an ACT kind of question. So learn how to do that one. And that's it. We're not doing any of the rest of this. Skip. And we are not doing a Friday quiz today. So, all right, cool. Those absolute values with the less thans and stuff, that will come in handy later. You'll be happy we did that. Okay, that's all I got for you for today.